If we're going to do safety engineering, we need a risk goal. We need to understand how much risk we're willing to accept to understand how safe is safe enough. And to do that, we need a framework for expressing the risk. It turns out there are multiple different ways to think about how much risk might be enough. One of them is minimum endogenous mortality. The idea here is that everyday life has a certain amount of risk, and especially when you're younger and old age diseases are not a big factor on mortality rates, there's a certain risk that people will die from whatever reason. Think of it as a background risk of living in our society. And the idea of MEM is if you're going to build a system, that system should not significantly increase the risk to the population. Well, it turns out that driving in ordinary cars is a non-negligible risk. There's a significant risk there. Saying autonomous vehicles will have negligible risk compared to all the other things that happen in life is unreasonable. I mean, that would be great. The folks who want there to be essentially zero mortalities from this technology, that's kind of what they have in mind. That's effectively zero, but that's unrealistic. There are other frameworks that are probably more likely to be used, at least in the near term, and MEM would be a much longer term goal. Another framework is ALARP, as low as reasonably practicable. There are some other concepts that are related to that. But the idea here is that you reduce any risks identified unless the cost is extreme. How extreme is an interesting question, but you're expected to spend a lot more to reduce risks if it's feasible to do so compared to just paying out the insurance costs or something like that. So if there's a way to reduce risk and it's practicable to do so, you need to do it. Another less rigorous way of thinking about risk is NMAU, which is reducing the identified risks within a reasonable cost. So here the bar is set a little bit lower, as long as you know how to reduce the risk and the cost is reasonable, you have to do so. So it's along the lines of ALARP, but the bar is kind of set lower. The issue here, which is also true of ALARP, but especially here, is what if we don't know how to build something safe? If you build something and reduce the risk within reason, it might end up being unacceptably dangerous for society. So these are principles you're going to want to see. Certainly if there's a way to make something safer that's not expensive, you should do so. But it doesn't mean that it's going to be safe enough for societal acceptance. We need to have something a little bit stronger than that. There's the classic engineering approaches, safety integrity levels. In automotive, it's automotive safety integrity levels, ASIL, which are associated with the standard ISO 26262 that we'll talk about later. And the idea there is not to actually measure the risk, at least in that standard, but rather to say, here's what the risk is, and we have a menu of engineering approaches we're going to apply, and the more risk, the more engineering approaches we apply to mitigate the risk to something that we think will be acceptable. So it's not actually a measurement of the risk itself, but rather an engineering methodology to bring rigor to the table when there's high risk. We'll probably see this used, but as with other techniques, this may not be enough because it's not specifically designed to cover the machine learning technology that's behind autonomous vehicles. So it's a piece, but it's not going to be the final acceptance criteria probably. The final acceptance criteria is probably using the GAMAB risk framework. The idea here is you take an existing system, human-driven vehicles, and you say, well, we're going to build a new system to replace it. And the concept is the new system will be at least as good as the old system. So when you hear people talking about, well, as long as it's as safe as a human driver, then it's okay, they're talking about a GAMAB approach.